Welcome! In this video, I'm going to demonstrate how to use the Prisma Data Proxy and show how it can solve some of the connection pooling problems that are very common to serverless runtimes. And so just to recap, the common challenge with serverless environments is that a single serverless function handles a single user request. And every time one of these serverless functions starts, it opens up a new connection to the database. Now, the moment that you reach a lot of requests coming into your serverless functions, what happens typically is that your database connection limit is exhausted. Moreover, opening up a connection and closing it for every user request to the database is quite costly time-wise, and it adds latency. So beyond the connection limit exhaustion, which leads to failed requests, there's also the added overhead, which adds slowness. This is where connection pullers come in. Some of you may be familiar with PG Bouncer, a Postgres-specific connection puller that helps solve this problem. However, typically PG Bouncer is an additional infrastructure component that you need to run. As part of the Prisma Data Platform, our vision to democratize data access and make it as easy as possible to collaborate and to iterate on projects using a database and Prisma, we are now introducing the early access version of the Prisma Data Proxy. In this video, we're going to deploy a Next.js application that uses Prisma to Vercel, and initially we're going to deploy that without the Prisma Data Proxy. We'll run a load test to see how it performs and to see the kinds of errors that you encounter typically without any connection pooling. And then we will add the Prisma Data Proxy and see how it performs with that. So here on the left-hand side, you can see what it looks like when we just have the Vercel functions connecting directly to the database. And then once we introduce the data proxy, it will act as an intermediate infrastructure component that is, of course, managed by Prisma and handles this connection pooling for you. One thing to note is that there is an additional benefit to using the Prisma Data Proxy. By using the Prisma Data Proxy, you essentially eliminate the need to also package the Prisma engine into your serverless function. This should result also in faster loading times of these serverless functions because it takes less time for them to load because of their lower, smaller bundle size. Let's start by looking at the app. So here on the left-hand side, we have this blog, and this blog is built with Next.js. It uses Prisma. As we can see on the right-hand side, we have the Prisma for this project. So we have a single post model and a comment model with a one-to-many relation between posts and comments. In practice, this is what it looks like. If I open up the page, you can see here that I have a single blog post and the different comments. I can also leave comments, and you can also see we have API endpoints to increment the views count and also an API endpoint so that we can increment the likes for each blog post. And if we look at the right-hand side here, we have the Prisma schema, and let's take a look at some of the API methods. So this is the API route to add a comment to a blog post. As you can see, it creates it and it links it to the post ID that gets passed in to the request body. We also have the post endpoint. This one supports two HTTP methods, one to get to get multiple blog posts, and one in order to create one blog post with a bunch of comments. We also have an endpoint which deletes a specific blog post. So this is the one that gets called if I click delete post, and as you can see, it's been removed. And we also have the two endpoints to increment likes and views. And here we're using these atomic operations that Prisma Client supports so that you can ensure that it's incremented by one without actually having to fetch the data before. I also have this seed endpoint, which is called when I call reset posts, which deletes all of the posts and seeds the database with 4 blog posts. So this makes it just easier for us to sort of play around with this blog. You may also notice that there's a create post here. I showed you the endpoint for that, and that just creates a new post. I can click that, and as you can see, another one is created. Let's get started with deploying this application. On the right hand side, you can see I've pushed all of the changes to GitHub, and on the left hand side, I have the import window of Vercel. You can already see that in the package.json, I've defined this Vercel step that will just run Prisma generate and next build. I'm now going to go ahead and import this project. I'm not going to create a team, and I'm going to have to define an environment variable here for the database. So let me just copy that in base URL. I'm going to paste that, and now we can go ahead and deploy this. Great, we've successfully deployed the application. Let's take a look at that. So we go to the dashboard and then open up the app, and as we can see, we have it. We can also open these up and we can like them, we can leave a comment, and that is all working. We will now look at some of the challenges that typically arise in such situations where you're connecting directly to the database from serverless functions. So quick reminder, serverless functions are ephemeral and short-lived. That means that their database connections are numerous and brief. Because of this, using relational database in serverless environments and functions often leads to exhausting the connection limit of the database and to increased latencies on each request to establish the database connection. So let's take a look at what a load test to this API looks like and how the API performs under load. For this, I have prepared a load test, and the code for the load test is here on the left. This is using a load testing tool called K6. And here we define a user flow that makes a bunch of requests to the API. It gets the blog posts, it creates a blog post, it adds a comment, it adds a like and a view to each one of these, and it does this here. You can see in the configuration that I have 40 virtual users. So that means that 40 users will go through this user flow, and the duration of this load test will be 10 seconds. So let's run this load test. And what I expect to see is some failed requests as we exhaust the database connection limit. And you can see that already through the errors. Once this load test finishes, we'll get the full results for how the test ran. And so now that it's finished, we can see that the status was 200 for only 81% of the get post requests, and similarly for the other endpoints. And if we look at the logs in Vercel, we expect to see these errors. So basically we get these errors that show us that the connection limit of the database has been exhausted. Okay, how can we fix this? This is where the Prisma Data Proxy comes in. To make use of the Prisma Data Proxy, we first have to create the project in the Prisma Data Platform. To do this, I'm already logged in, so I'm going to go ahead and import a project. And I'm going to call this the Next Prisma Data Proxy. I'm going to also tell it which repository, so Next Prisma Data Proxy, and it already detected where the schema is, and I'm going to create the project. Now that the project has been created, I'm going to connect it to an existing database, and for that, I'm going to take the environment variable. I'm going to paste that in. Now it's connecting to the database, and we are connected. Now that we have the database connected, I want to show some of the functionality that the Prisma Data Platform offers. So the first thing we have is the data browser. And the data browser essentially allows us to explore the data that we have in the database. It's essentially based on Prisma Studio with some added functionality. So for example, we have here the 4 blog posts. We can see that this one has 3 comments, and we can see what those comments are. One of them has 4 comments. And we can also use this in order to modify some of the data. So I could go ahead and read this, and I could save those changes, and essentially this allows us to update our data in the database. And now it's reloading and we see the update. We can also explore the different comments that we have by opening that up. Okay, that was the data browser. We can also invite other members to collaborate and to also be able to access the Prisma Data Platform and to explore the data. We have a bunch of different roles so that you can control what permission level you want to give to your collaborators. The other thing we have is the query console. And the query console is a good place if you just want to sort of get started and play out and see what Prisma Client looks like. So for example, here I created a query that finds all the posts, and it also selects the relation count. So it'll actually give us the number of comments that each one of these blog posts has, and then it will combine that with a feature known as order by relation in order to order the blog posts in descending order by the number of comments that they have. And so if I run this query, I expect to see, of course, the first one with 4 comments, and then the second one with 3 comments. Same thing with the third one, and then finally the one that has 2 comments. I can also, of course, change this to ascending order. And of course, I can also write additional queries, like I can write await prisma.post.find many, and then I can also order that by the title in descending, or let's do ascending order. And as you can see, you still get in this query console, you get the same auto completion that you get in VS Code. So that was the query console, but we want to look at the data proxy. So let's take a look at that. Here, when we go to data proxy, we can essentially select one of the 2 locations that are available. These are deployed onto AWS, and of course this is, I should mention that this is an early access version, so expect this to get even more polished. So I'm going to pick Frankfurt because that is also the same region that I'm using for my database, and I will enable it. And now we got this new connection string, and now that we have this new connection string and the token, we can read the docs on how to get this set up with Vercel. So here I have the Prisma Data Proxy public docs for the early access program. And besides an introduction, we go to the steps about how to switch to the data proxy. And the first step, as we've already done, is generating this data proxy connection string, which we have already done. I've pasted that locally so that I can use that to also update the Vercel secret. And then the second step is that we have to install a special version of Prisma. This is while this is still in early access. And so I'm going to go ahead to the package JSON of the project and update the Prisma dependencies. So here I have it, and I'm going to just change that to use the special version and then go to install that. And we have that, so that's been installed successfully. Now we can go into our schema and then follow the next steps of the guide. And the main thing that we need to do here is we need to tell the generator block to use the data proxy engine type. And so I'm going to copy this line here and I'm going to paste it in. I'm going to format this so that it looks nice. And we are pretty much ready. You can go npx prisma generate now. And locally, I can already connect through the data proxy to the production database. So we will start with that. And I will go ahead and make sure that my end file is updated. And so here I have the end file, and I'm just going to disable the line that connects directly to the database and use the data proxy URL. And you can detect that because it starts with this Prisma. That's how you know that you're connecting through the data proxy URL. So now that that's working, I can go ahead and already start the development server and npm run dev, and that will essentially run the development server for Next.js. And if I open this up, we should see that it's connecting through this. If I go and I create a post, that is making an API request, and we can open this up already. And so now that we've opened this up, I can also add comment from demo. And we can now go back to, we can also like the page. And now we can go to the Prisma Data Platform into the data browser in order to see if the data has been updated. So I'm going to go here to the data browser. And in the data browser, I expect to have those 4 posts that were seeded plus the additional one that we just created. And let's go look at the posts, and it's fetching the rows from the database table. And here we have it. It has a single view and a single like, and it also has 4 comments. And if we open that up, we should see that comment that I just created. And there we go. There we have it. We have this add comment from demo. So that's all working locally. In the next step, what we're going to do is we're going to actually configure Vercel to connect through the data proxy to the database. And just a quick reminder, we had this sort of diagram here visualizing this. So essentially right now we have the Vercel functions. They're configured to connect directly to the Postgres database on DigitalOcean. And we are going to change that. We're going to commit the changes because we need to use the special version of Prisma in the package JSON that we updated. And we're also going to update the secret so that the functions connect to the data proxy. So let's take a look at how that works. Before we update the secrets on Vercel, I'd like to commit the changes to the Prisma schema and to the package JSON. Quick reminder that in the package JSON, we updated the dependency to use the special version for the early access program to connect to the data proxy. And the second change was in the Prisma schema, where we added the engine type data proxy. And so we will commit this now, but we will not push this just yet, because pushing this will trigger another build, and we want the build to start only once we've also updated the environment variables. So I'm going to commit the changes here and update to use data proxy. And I will save that. And now that we've committed this, we can go to Vercel and update the environment variables. I am now here in the Vercel project settings. I'm going to go to the settings and to the environment variables. And as you can see, we also have this database URL here. And if I view it, you can see that it starts with Postgres. That means that it is the connection string directly to the database. And we're going to first rename this. We're going to also need this in order to run migrations. So a quick pointer here is that when you are using the Prisma Data Proxy, you cannot run migrations through the Prisma Data Proxy. And so what we're going to do is we're going to create 2 database connection strings. One is going to be used in order to run migrations, and we will call that the migrate database URL. And then we'll just have the normal database URL, which is used in order to connect through Prisma client to the data proxy. So first step, I'm going to edit this, and I'm going to rename this to migrate database URL. I'm going to save this. And then we will go here and we will call this database URL. And I'm going to paste the connection string that I got from the Prisma Data Proxy, and I will add this. And this is pretty much all we need to do. We're now going to go back to the code base, and we are going to change in the package JSON here. We're going to change this migrate deploy command, and we're going to change this to be as follows. So it's going to look like this. And basically what this will do is it'll reassign the database URL to use this one that connects directly to the database, and then run deploy. To make sure that migrations are applied during the Vercel build step, we're going to add the npm run migrate deploy to the Vercel build step. Now that we've done that, I'm going to commit this change to, and directly. And now I'm going to push this. Now that it's pushed, we can open up Vercel again and see what is the current state. if we look at the deployments, we have this one which was triggered by the push. And we can take a look at how that's going. We should also be able to see it attempting to run the migrations because we've updated this Vercel build step in the package JSON. And indeed, here we have it. This is where it's running these migrations, and you can see that it's running them against DigitalOcean, but there are obviously no pending migrations to apply. That's because we've already ran the migrations. And so it looks like the build is almost complete. And once the build completes, we're going to open up the deployed app and take a look at how that works. And then we're going to run a load test to see how this application fares with heavy load and whether it exhausts connections as we expect it to. The Prisma Data Proxy will handle all of the connection pooling, and we shouldn't see the same errors that we saw as we did in the first load test. We are now going to run a load test against the deployed API using the Prisma Data Proxy from my local machine. We're going to use the exact same load test that we used before, that gets a post, creates a post, adds a comment, increments the views, and increments the likes for that created post. So let's go ahead and run that, and this test will run with 40 virtual users. That means that 40 users will be running through that load test concurrently, and we expect to see that none of the requests fail. Here we have the results from the first load test that was connecting directly to the database from the Vercel functions, and on the right-hand side we have the version that we just ran of the load test, which uses the Prisma Data Proxy in between. And indeed, we can see that here that 1,115 requests were sent in total. That means about 96 requests per second, which is quite a high load. And if we see here at the number of requests that have failed, we can see that that's 0%. So here we have it. First of all, we've eliminated the connection pooling problem. We're no longer exhausting the connection limit of the database. And let's take a quick look at some of the performance for all of these endpoints. And we have that here in these first lines that we have highlighted here. And what we can see is that some of the endpoints average at about 150 milliseconds. But the main thing to note here is that we no longer have the database connection exhaustion problem. Another reason for this deviation that we're seeing for some of the requests could be the cold start problem. And the cold start problem could be stated as the situation in which you're calling a serverless function for the first time and it is not loaded in cache, which means that AWS Lambda in this case has to sort of load that function for it to run. And after it's loaded, AWS Lambda keeps it around in case another request comes in. And when another request comes in, it reuses that existing hot function or container. These are all terms referring to the same thing. And so this might be a good explanation for why we're seeing such a deviation from the minimum amount of time to the average, which is a bit higher. But the good news is that in the minimum case, when there is no cold start, we get a response pretty quickly within under 100 milliseconds. Let's summarize what we did today. Initially, we started off with a Next.js project that used Prisma. Prisma was used both in the server-side rendering and the static site generation using the getStaticProps of Next.js. We can also take a look at the API endpoints, for example, the getPosts endpoint and the single delete post endpoint. So all of these endpoints were using Prisma in order to interact with the database. We imported the project into Vercel, where it was deployed, and we connected it with a database that I created in the same region, the Frankfurt region. And after we connected to the database, we looked at it, we ran the load test, and we saw how many of the requests failed because of the database connection exhaustion. That's when we introduced the Prisma Data Platform. And a quick refresher, essentially we were going directly from the Vercel functions to the database, and that resulted in that connection exhaustion. And then once we introduced the Prisma Data Proxy, that was able to hold the connection pool to the database in DigitalOcean, which then eliminated a lot of the errors that we saw in the load test. And so here I still have the app that is deployed using the Prisma Data Proxy, and I can go ahead and create a blog post. I can open that blog post up, and I can go ahead and increment the likes. I can also add a new comment. And if I open up the developer tools here, we will see this request, and this request was served within 87 milliseconds. Let's take a look at how long it takes to make a call to increment the views. And there we have it, within 80 milliseconds. That was pretty good latency. I should note at this point that while the Prisma Data Proxy solves a lot of the problems associated with serverless, we may still see some problem known as the cold start problem. And the cold start problem could be stated as the situation in which a serverless function is instantiated for the first time and it is not cached. And so the runtime, in this case AWS Lambda, has to actually load up the function in order to serve the user request. Typically what happens is that AWS Lambda keeps that serverless function around in case another request comes in. And when the following request comes in, it's usually served much quicker. And so I expect that these low latencies that we're seeing now are thanks to a hot start of a serverless function, probably because I've already been interacting with this app, and because AWS keeps them around for a couple of minutes. So on that note, we'll wrap up. I highly recommend, if you haven't already, sign up for the early access program in order to try out the Prisma Data Proxy. And if you have any questions, please be sure to leave them in the comments.